Hello, Professor. My name is Raul Barrera. So, my initial intention was to write the problem as I was speaking. However, I messed up while screen recording. So, what I'm going to do is I am going to explain my work while I speak. So, for example, we are working on 21.74. We are solving first for part A, and then we will be solving for part B. So, for part A, we want to know which ball has a positive charge. In order for me to help out, I always need to have a visual orientation. So this is a diagram from the book. So we have two balls, one in the left, one in the right. We have an angle here, and it's a triangle or shape. So we want to know for part A which ball has a positive charge. So since the balls have opposite charges from one another, they will have to attract each other. The gravitational force and tension in this string works to bring the balls to their original position, which is right here in the middle. In order to do that, the electric force only pushes the charges apart to balance the previous attractive force. So the direction electric force on the right hand must be negative. And the the electric force on the the left side must be positive. And the right side must be negative. When this happens, what they do is that the left ball must be negative and the right ball must be positive. This will cause them to come back to their original position, which they are doing by attracting one another. Now, for part B, they want to know what the magnitude of the field is. So, by doing this, I decided to go with the method of using the sigma force. First, I'm going to solve for y, and then I solved for the x direction. They are both very similar methods. I want Fy equals m a over y. Then I use cosine, t cosine, theta over 2 minus mg will equal 0. T equals mg over cosine 0. Moving on, we are doing the same equation, but for the x direction, which is f of x equals max. So this is the equation. Instead of using cosine, we are now using sine because we are in the x-axis. So pi over 2, angle over 2, also known as the theta over 2 minus f equals 0. So this is what we are left over with. Now, we then have to use both figures and the distance between the two charges, which this is given in the problem, and this is knowledge that we should have known in order to solve the problem, which we need d over 2 equals 2 length 2 sine square theta plus 2 plus 2l square sine square theta square. And this gives us d2 equals 4l sine square over theta square. It's 2. And then it's d 2l, which you see how this, we have to simplify to this, is d equals, instead of 4l squared, is 2l sine theta over 2. Then moving on, we need to substitute k, q over d2 for f. Sorry, give me 1 second. Let me clear out this work area. Don't delete anything. Okay. And 2l sine over theta over square for d. So now we start by using this formula, which we are substituting. E equals t sine theta over square plus kq square over d square. This gives us, takes us down here to simplify it. It's t sine theta over square over q plus kq over 2l sine theta square. We're almost there. We need a few more steps in order to get the magnitude. Now we need to substitute mj over cosine theta square for t, we do this by using the same method right over here. mj over cosine theta squared sine theta over half over q plus kq 4L squared sine squared theta over 2. Then brings us down here is mj tangent, because it's sine over cosine from the both equations that we have done, theta over square over q plus kq 4L sine square theta over square. Now all this information was given to us in the word problem. All I did was get the information and I categorize them, as you can see here, by what they are in the problem: our angle, our length, and so forth and so on. So for M, we had 6.8 kilograms. For G, we had, which is the time, speed, we had 9.8 meter over second square. The length, 5.3.530. The angle, 58. And then all I did was plug it in to the equation. And as you can see, it didn't fit on my screen. So this is the first part of the equation. And this is the second part right down here. It's just that I had to add. We put all our angles together, 6.8 over 1 kilogram over 10 mg, 9.8 meters over square tangent, 58, which is our angle, over 2. That's what we're trying to find out. 72 NC, 1C over 10C, and so far and so on. I did the same thing in the second equation right over here. Plus this brings us down to this. When we simplify this and add it to each other, we get 29.6713 NC, which that is our total magnitude. Again, it was supposed to be narrating over while I did the work. However, I messed up, so I only have the screen recording for the work. So I had to make another one with my voice over it. I hope it was well done. If you have any further questions, Professor, feel free to reach out to me. I will get that done as soon as possible. Thank you very much. Just wanted to let you know that I appreciate your class, and I know there's a lot going on, but I feel like we're all doing a good job, and we'll eventually unite ourselves as a class. But I respect what you're doing. Appreciate it, and stay safe. Have a beautiful day.